Okay, I think we'll go ahead and get started. Let me go ahead and open this up in prayer, and I'll give you a sense of the things that we're going to be focusing on today. So, dear Heavenly Father, Lord, thank you for the chance to be working with the students in this course. I pray that the material will be clear. Pray it can be interesting and an enjoyable experience to get an introduction to engineering and computing principles. Pray that you would help them in their spiritual formation, Lord, that the times that they can be studying scripture will be rewarding, and that they can cherish those times in their heart, and that they can be drawing the theological concepts and how we can be ordering our lives from that, and give us all interesting and creative ways for faith integration. In Jesus' precious name we pray. Amen. Okay, well, what I wanted to cover today is I'll be focusing on, let's have a discussion afterwards, but we're in this section now where we're doing computational analysis. And so this is something that you would be doing both for engineering projects as well as for application computer science related things. You're trying to be thinking about, well, am I solving the right problem? You know, what is a problem? How is it well defined? What are the requirements? And then you want to start to be playing it out, doing some graphs, flow charts, things like that. And so what we're going to be talking about today is a fairly popular and well-established tool called MATLAB. And when I did an informal query, it seemed like a lot of students were not using MATLAB, but still I have pulled in some videos from MathWorks education for us to be seeing some of these capabilities. And I think just have you seen some of that capabilities will give you some insight into how it might be of use. One of the courses I teach elsewhere is actually in machine learning. And one of the things we actually use is we use MATLAB as one of the ways that you can be doing some machine learning development or an assessment. Also, I'm going to try and show something like that in Python. Anybody ever heard of Juniper Notebooks? This is probably more of a question for the computer science folks. Have you ever heard of Juniper Notebooks? Okay. Well, it's one of the ways that you can have multiple lines of scripting in Python and then execute it. And then it stores those variables and you can do your next section of code. And so you can be doing one thing at a time. And actually MATLAB now has a way of doing that as well. So let's think about what we're going to be covering in this course. And so I'll just open this up to see if anybody has any comments on this, but if you haven't used MATLAB, it may not be something you're familiar with. Write a few sentences responding to the following prompt. Discuss the basic makeup of MATLAB. Discuss what you know about computational engineering tools. And so let me just see if anybody has some thoughts on that. So some of you guys are definitely engineers, and you can relate to where and how would you be doing some computational operations, and how would MATLAB be helpful? So maybe I'll start to a little bit more basic. How many before this class ever heard MATLAB or MathWorks? Is that something that you guys have ever bumped into? You can just do a thumbs up or if you've heard of them. Okay. So it sounds like we're starting from scratch. And we'll go ahead and have that as a perspective. And so thank you for letting me know about that. So since most of maybe almost all of you have never heard of MATLAB, we'll start to get a chance to be thinking about the basics. And it's a very powerful program. It's been in development for a number of decades. We'll also be looking at functions, loop control, and conditional statements. You actually program in MATLAB. If some of you are familiar with Fortran or BASIC, maybe you might have heard them. For some of the programmers, kind of has some look and feel for that kind of sequential type of programming. It's not object-oriented programming in its basic state. You also can do plotting. You can also do plotting in Excel. This is one of the things why I was having us start to be thinking like what I did last week when I was looking at Excel. was I was just starting to show how you could be using it and to come up with scenarios. And so how do you know you're sizing your application for the right level? How do I know that I'm building a engineering project with the right type of robustness that's going to have things work over time? I'm sure you've seen various videos of like bridges that have collapsed. And so you could argue that they were under-designed. And so maybe they didn't have the enough of the worst case options that they were considering such that that would have been considered. You can also do matrix computation. And I do have a MATLAB example for the mechanical engineer leaning folks in our course. I think you'll love it. It's analyzing a truss. And so I'm not going to show that today. And I'm also just going to keep it at a top level, but it is a fairly developed type of program that you'll get a chance to be seen. There's a lot of equations that are then put into mathematical form that you can execute, and you can have certain conditions, like say the wind going at 30 miles an hour from the east, and you could be seeing how much the structure deforms to try and see if it just remains in a stress. Stress means that you're going to go back to the original state. Strain means it's enough that it's going to deform the structure. And so for civil engineers and mechanical engineers, those are the kind of things that you want to be avoiding. There's also something that you can do, symbolic mathematics. And so you can solve equations. You can be thinking of quadratic equations or algebra. Those are also some things that you can do in MATLAB. That's a more recent development in terms of some of the things that I'm familiar that MATLAB can do. So it's an all-purpose environment. So it originally was designed to manipulate matrices. Today, it can be used to carry out a wide range of mathematical operations. We'll have a video on the environment, but you can assign values to a variable or define the elements of a matrix. All of those are possible. You can also use MATLAB to input engineering formulas and compute the results. When typing your formula, you use using parentheses can dictate the order of operations. So it's just like typing on a piece of paper that you can be spelling out your equations. So there's a couple things that I'm going to be showing in this figure here. This is what the general GUI looks like for MATLAB. There's a menu bar, there's a current folder window, command history, and workspace. And we'll have a video that will be highlighting that in a little bit easier, hopefully a little bit easier than seeing this image. And so this will be the first of several videos. And so this one's fairly short, is just trying to talk about the impact and value of MATLAB.
Millions of engineers and scientists use MATLAB to analyze the data, develop the algorithms, and create the systems that shape the world around us. At the heart of MATLAB is a high-level programming language that lets engineers and scientists express matrix and array mathematics directly. MATLAB provides a vast library of toolboxes that spans everything from signal and image processing, control systems, wireless communications, and computational finance, to robotics, deep learning and AI, and more. Created specifically for engineers and scientists, MATLAB is designed for the way you think. Easy to learn and use, it lets you express your ideas directly and puts the tools you need at your fingertips. Explore ideas quickly. See results and visualizations right next to the code that produced them. And only MATLAB includes pre-built apps and allows you to easily build your own, for when point and click is the best way to analyze and design. Extend MATLAB with thousands of packages and toolboxes shared on GitHub and elsewhere. Then deploy your work on cloud and enterprise systems, into Simulink, or automatically generate code that runs on embedded devices. From researching the world around us to creating next-generation intelligent systems, millions of engineers and scientists use MATLAB to shape the future. What will you do with MATLAB?
Does that draw an impression from any of you guys as you see that? For some of you, it sounds pretty exciting and it's kind of the sky's the limit. So I'm not trying to do a MATLAB commercial, but having you think that this is one of the tools that's available. And if you just quickly saw some of those figures that you can do what if kind of things. And if you did this, you change this, you can see it in a graphical way. You can have various ways of highlighting that data. So it's really amazing how much you can be doing. So there's various kinds of commands that you can be doing. I'm not going to be focusing on these since the majority of you aren't going to be using MATLAB. I'm going to let the videos kind of highlight some of the things that we can get into a little bit more detail. There's certain ways and constructs you want to be using an underscore rather than a dash for if you're going to be creating a file name and stuff like that. It's just one of the things I learned the hard way. The way that you do arrays and stuff like that, you use a colon. So that's a little bit of something, can take a little practice, but basically this is just talking a little bit about the syntax, and like I'm not going to get too in detail about that, but for those that are going to be using MATLAB, a couple of these charts like these ones might be helpful, but it's quite easy. There's plenty of sample programs that MATLAB makes available. So if you choose to try it out, I think you'll have a lot of fun. And so this will be the, I'll probably have about 5 or 6 videos interspersed in a handful of charts. And so this is the development environment. So once again, think about what do you want to do analysis on with your project? What needs to be explored? And so if you're trying to help a friend or relative or a category of individuals that say want to be working on their fitness, and so how are you going to show progress? You can be thinking about that. If some of the folks are looking at, turning plastics into petroleum, or trying to get plastics that are floating in the ocean recycled, to the sky's the limit, but we'll be thinking about that. But as we're seeing some of these videos and getting an introduction to MATLAB, we'll focus on that in a conversation at the end. So here is the development environment. Well, I'm not sure why that one's not working, so I'll just save that towards the end to see if I can get it to go here. See if this one works. Okay.
MATLAB is an environment for all kinds of technical computing, like data analysis, simulation, and algorithm development. This video will show you the basics and give you an idea of what working in MATLAB looks like. Be sure to stay to the end to find out where to go next to learn MATLAB in depth. So let's get started. This is one of the buildings at MathWorks headquarters in Natick, Massachusetts. See all those nice solar panels? Well, let's see if they're working properly. There's a theoretical model that says what the energy production should be. Let's implement that and compare it with the actual data recorded from the panels. First, we need some constants: the latitude of Natick and the solar declination, which is just an angle that tells us how high in the sky the sun gets on a given day. These are values that we can look up. Let's use the value for June 21st, the longest day of the year. So that will give us the maximum amount of production. Our calculations are entered in the command window and executed immediately. We can see the variables we've just created over here in the workspace. The angles we've just entered are in degrees, but if we're going to do math with them, it might be better to convert them to radians. We can do standard mathematical calculations and assign a result to a new variable, or even overwrite the same variable. Here we're using the built-in value of pi to do the conversion manually, but we could also use one of the many built-in MATLAB functions. Next, we want to calculate the production throughout the day, so we need a range of times. Let's make a vector to represent time of day. We'll start at 5:30, a little after sunrise, and go in 15-minute increments until 8 o'clock, just before sunset. Our formula uses local solar time. That's not exactly the same as the time on the clock because of conventions like time zones and daylight saving. So we'll take our vector of times and apply a shift. And now we're ready to calculate the effect of the angle between the sun and the planets. This equation is long, but the MATLAB code looks just like the map, so it's easy enough to implement. Again, this part of the formula is assuming degrees instead of radians. So we could convert, or we could look at the documentation to get more information about trigonometric functions, where we discover that there's a cos-d function that accepts inputs in degrees rather than radians. MATLAB has functions for all sorts of things, so it's always good to check the documentation. Now that we know about cos-d, we can complete our formula. And let's add a semicolon to the end of the line, so the result isn't displayed. If we want to look at the values, we can always double-click on the sun angle variable in the workspace. It opens up the variable editor. But it's probably more informative to view it graphically. We can select the variables t and sun angle and go to the plots tab in the tool script. Select a plot, and there it is. And now we also have the code, so we know how to do that programmatically next time. The intensity of radiation due to the angle of the sun should be 0 as the sun rises and sets, and peak at local noon. And we should get 100% intensity when the sun is directly over the planets. But in Massachusetts, the sun never gets directly overhead, even in June, so the plot looks about right. Okay, that's the angle of the sun accounted for. To complete the model, we need to calculate the effect of the atmosphere. The more air the light has to pass through, the less energy makes it to the panels. Let's enter this empirical equation and, something went wrong. Fortunately, this helpful error message lets us know that we made a common mistake. MATLAB works naturally with vectors and matrices, including doing matrix math. So by default, MATLAB thinks this caret is a matrix exponential. But that's not what we meant. We want the exponent for each element of the array. So let's use the up arrow to recall that command, then do what the error message says, and change the exponent operation to dot caret. Finally, we just need to multiply the two intensity factors together. And we've learned from the previous error, so we'll use dot star this time. And multiply by the size of the panels to get the total theoretical energy production. Check the plot. Looks reasonable, so there it is. The theoretical maximum production we should get from our solar panels. This is what we should see on June 21st if it's a perfect sunny day. Next, we need to get the actual data and compare the two. But before doing that, it might be a good idea to save what we've done in a script. Let's go back through the command history and select the commands we used to get here. Right-click and select Create Live Script. This opens the editor with a script containing the selected commands. We can now edit the commands, and because we have a live script, we can make this more usable by splitting into sections, adding text, comments, headers, images, equations, and so on. Now we can run sections of code or the whole script, and the output appears in the output panel next to the code. We can use the interactive tools to clean up our plots. And again, we get the code so we can add it to our script. Now for the data. In the current folder browser, we can see that we have a spreadsheet that contains the recorded production for June 2018. Let's import that data. The import tool looks at the contents of the file. It recognizes the first column as timestamps, so wants to import those in a data type that's suitable for dates and times. It also wants to import all the data together as a table, which is a data type designed for this kind of spreadsheet data, where we have a bunch of observations and several different variables. So let's just import the data in this one, but maybe with a slightly simpler variable name. Now we have this variable, production, which is a table with 2,880 observations of 3 variables. The 3 variables are time and the electricity produced by 2 different solar panel arrays. Having imported some data, a good first step is often to plot it to get an idea of what you're dealing with. So let's use the plot function. To get the individual variables within a table, we use dot notation. The name of the table, dot, and the variable name. And note the useful programming aids that suggest completions. Run this section of the script to see the results. Because the timestamps were imported as a datetime variable, the x-axis of our plot is labeled as dates. So we can see the 30 daily spikes for the month of June. We can use the interactive tools to explore the plot a bit. We can see there are some cloudy days, including the 21st, unfortunately. But over here, you can see the 26th was perfect. So how do we get the production for one chosen day? Well, there are several different ways we can do this. But if we're interested in slicing the data by day or time of day, it might be useful to rearrange our data from one continuous time series to a grid of times and days. This approach makes sense for this data, which is recorded uniformly every 15 minutes. So the 2,880 measurements for June correspond to 96 measurements, 4 per hour, for each of the 30 days in the month. So let's use the reshape function to change the long vector into a 96 by 30 matrix. Now it's easy to extract the data for any given day. To get the data for the 21st, we go into our matrix and take all rows of the 21st column. This data is recorded throughout the day, so we need to make a vector of times from midnight to midnight. And now we can plot it. Let's add a style specification to show the actual data bits. And now we can give both the theory and the data to the plot function so we can see them together. As expected, the data for the 21st isn't very good. But remember that the 26th did look good, and a few days won't change the angle of the sun that much. So let's look at that day. Thankfully, it's easy to change to a different day and rerun the section. Now we can see that the data agrees with the model, well, up to a threshold of how much the inverters can handle. For our system, the panels can produce up to 270 kilowatts, but the inverters have a limit of 207 kilowatts. We can go back and use the min function to add this limiting behavior to our model. Rerun the script. And now we see the data agrees very well with the theoretical model. We've done some great work here, so we should share it. If we just want to share our findings with someone, we can save a copy of the script as a static document, like a PDF. But we can also give this script along with the data file to anyone with MATLAB, and they can run it for themselves and reproduce our results. They can edit the script, explore the data, refine the model, and perform new analysis. And you can too. These files are available for you to download. And now that you have a feel for what working in MATLAB is like, it's time to learn it properly. There's no better way to learn MATLAB than to work with it. So head over to MATLAB On Ramp, which will teach you the basics of MATLAB interactively. You'll actually enter MATLAB commands in our online training environment and get instant feedback. It's free and should take just a couple of hours. You can leave anytime and come back later. Welcome to MATLAB.
Any impressions about that?
Welcome, MATLAB user, to your
Any, partly when I see that, it seems overwhelming, you know, they went through that extremely fast, but I was trying to let you get a big picture perspective of the kind of things you could do. So the introductory video and this one, anybody have a thought? How about thumbs up if you think it might be useful? Anybody see that? Okay, so there isn't a right answer. So especially just for your project. So part of what I'm trying to do in this course is bring a survey, so you're going to get exposed to a variety of things. Sometimes I find that Excel can be a little bit more helpful because I can get going and completed with some results. Some of you in your midterm, you had some nice plots showing trending and stuff like that. You could do it in MATLAB, but it might be even easier to figure out how to do that in Excel or Python, or you can do some of the similar functions. But anyway, if you're starting to get a sense, like some of you are doing things related to solar panels, and you saw a complex equation that they had listed in there. And so the analytics for what would be needed for your business logic, thinking in terms of an application, you wanted to see what the solar production is. And I'll pull it up on my iPad. So those online, I'm sorry, you're not going to be able to see this, but my wife and I have a solar system at home. And one of the things that we can do is we can sample how things are doing anytime during the day or doing a history. So if I just go to the app, and so it's not very big, but let's see if I go like this, it makes it a little bit larger. And so that's the actual production of what's going on as of right now. And so if you can see it was where I live, it was a relatively sunny day. Yesterday, you can see that it was not quite as performing well. And we have a 6 kilowatt system. And so we're about the equinox, September 21st. And so it's not quite getting up to 6. It's only getting up to about the maximum at about 4, a little bit less. And so part of that is just due to the nature of the way our solar panels are laid on our roof, the angle of the sun. You might remember that they mentioned that in where they are in Massachusetts, the Northeast, that they never get full direct illumination. They're not on the equator. None of us in North America are going to be at the equator. If you went to Hawaii, for example, you're going to be a lot closer to that, but still it's not going to be right overhead. So thus you're getting an example to hear some of the complexity that can be associated with thinking about these things. And I know it kind of made our brains hurt a little bit to be thinking about all of these fundamental kind of elements and factors, force, time, mass, and all those things. But this is where we want to start to be thinking as engineers and computer scientists to be taking that information and starting to manipulate it towards it's producing a useful capability, technology, application, or something like that. So that's a lot. So let's have a little bit of a conversation and give me some of your thoughts. Anybody have some impressions where MATLAB might be useful? So let's pretend you're an engineer. Let's pretend you're in computer science. Anybody have some thoughts about that? Go ahead. Mm-hmm. Yeah. Yeah. Yeah, and they spent a lot of time having a interactive GUI. And so I'm not really getting into it, but here is MATLAB, but there's something called Simulink where you can actually run things as like a real-time simulation. That's a way you can be thinking the difference between MATLAB, where you're doing having an equation, then you solve that equation, and you can plot information. There's various ways that you can be engaging with that material. So that's another thing that's there. Any other thoughts or comments that come to mind as we're thinking about this? Yeah. Mm-hmm. Right. Mm-hmm. Good. So let's continue to be thinking about that. And towards the end, I'd like to have us do a little bit more focused discussion in terms of our projects. We can do that today as well as on Thursday. So then we have functions. You can do loops. So basic programming features that all the programmers in the room would be more familiar with, and all that is possible. So large selection of built-in functions. They were showing a couple of those in that video. Various controls, and so for and while would be example of those loops. Familiar terms for folks that have been doing a variety of program things. You can do logical and relational operations and or would be examples of logical operations, some of which you may be familiar with. You can have other conditional statements, if and else. And then you can store files that can then be loaded into MATLAB, data files. You can have .m, and then you can have actual MATLAB scripts. I think it's .mat. And so those are some things that we have there. So there's a variety of built-in functions that MATLAB has. And so we can take advantage of that. Well, what about plotting? Anybody have a speculation with what you're exploring? How do you think plotting would be helpful? Like they were showing examples of tables. Was that very easy for you to digest what kind of solar illumination that they were getting or production? Or was the graph? Which one do you think was easier for you to get your head around? Anybody have a thought on that? Yeah. And so that's when you get into engineering and computer science, you have complicated enough types of things going on that various ways of communicating things in graphs and figures and flowcharts are very valuable. And so that's the point I wanted to make in this context. And so let's just think about doing some basic plotting. And here's a video that will talk about that.
Hello and welcome back to another MATLAB video. Today we're going to be talking about using basic plotting functions in MATLAB. These functions are essential for anyone who wants to present data visually, since they provide a quick and easy way to make meaningful and interesting plots. Before we can make a plot, we need data to put in it. For this video, I will make two simple data sets, both made of 50 random numbers. And there we go. Now that our data is squared away, we can get down to plotting. To plot our first set of data, we use the plot command, and then a figure window pops up with our lovely data plotted in it. We can also plot our second set of data using the same command. These plots look good, but most of the plots out there have an X and a Y axis. So let's make an X axis. Let's make a T data set for, say, time, using the linspace function that goes from 0 to 0.01 in 50 steps. Now, when we plot T against Y, you can see the X axis labels have changed, as is the same when we plot T against Y2. So, now we have some solid plots, but they only appear in a figure window, then disappear as soon as we plot something else. Never fear, to make a plot stick around when we plot something else, just use the hold on command. Now, when I plot T versus Y and T versus Y2, they both appear on the same axes. After you're done admiring your two plots sharing the same axes, use the hold off command to release the axes sharing capability. To dock your plot figure onto the desktop, click here. And to undock, click here. To interactively zoom and pan around in your plot, simply hover over the plot figure and either scroll in and out to zoom, or click and drag to pan. You can also use the Axes toolbar to do these functionalities as well as others with the home button restoring the original dimensions of your plot. Now that we know how to navigate with our plots on the MATLAB interface, we still need to make our plot more meaningful than just some lines on a screen. To do this, let's add a title, some axes labels, and a legend. There, our plot is now meaningful. If we want to change up the way our plot aesthetically looks, we can add markers, change their style, change the line style, and change the line and marker size and color. For more line and marker options, as well as other information regarding plotting, consult the help menu in the upper right-hand corner of the screen. Now that we've created some nice looking plots through MATLAB commands, we can save them into a live script to edit and run them later. And voila! Your plotting script is now saved, and you successfully figured out the basics of plotting in MATLAB. Thanks for tuning in, and I'll see you guys in another video.
MATLAB stores all types of data in arrays. This includes not only
Okay,
MATLAB stores all
so that just gives us a little bit of an idea of plotting. One of the things you saw, they had two figures so you could say like, two different runs. Or maybe you have somebody that's trying to work on their fitness and they have their caloric intake that they did on day one, the caloric intake what they did on day two. And you could see some trending data. Or maybe what kind of nutrition they had. And so you could be seeing things like that. Those are maybe some possibilities that you can be thinking of in terms of your data set. You can import Excel and other data files into MATLAB, and so that's something. So maybe you've done some manipulation manually, now you want to import it into something like MATLAB, that would definitely be possible. Anybody have a thought of what you think the answer would be for this? MATLAB offers many choices when it comes to creating matrices, charts, codes. Anybody have a charts? Yep. So all of these different kinds, you can be doing histograms as well as all kinds of different types of plots. And so we can also do matrix computations, and I'll show one on a truss that it has some matrices, but you were seeing just with some of the data sets, you can think of like taking how much solar power was generated, taking 10-minute snapshots every day, that would quickly turn into a matrix. And so how did the production vary at 12 noon over the last 20 days? So you can do all kinds of interesting matrix types of activities in MATLAB. So you can do curve fitting. And so you can be fitting in some data and it's going to give you a way, what would be an equation that would represent that data. And you could be specifying to what level of it's tracking. Sometimes if there's noise in the data, you may want to just do some averaging. And so an average kind of way of looking at a plot, all of those things are possible. I think this is the last video. So hopefully this one will work as well. And we'll just, for the interactive part of an exploration of MATLAB, we'll finish with this.
Hello and welcome back to another MATLAB video. The objective of this video is to show you how to create and run a basic MATLAB program. So if we open up MATLAB, we'll see a big panel in the middle. This is called the command window. The command window is used to execute commands one by one. I'll show you what I mean. We can create a vector x that goes from 1 to 10. And when I hit enter, this vector is created in our workspace. Or I can create a vector y, which is equal to the square root of x. And when I hit enter, this vector is also created. Or I can even create a plot from these two vectors. And when I hit enter, this figure pops up on the front of my screen. So as we can see, the command window is great if you want to execute commands line by line. But what if you want to execute multiple commands at a time? Well, you can do this by creating a live script. Let's close out of this figure and I'll show you two ways to accomplish this. The first way is to click New and then Live Script. And when you do this, you'll see the Live Editor window pop up on top of the command window. Here, you can type multiple commands without executing them right away. But let's say you already typed a bunch of code in the command window and you want to preserve it for when you create your live script. How do you do that? First, go to your command history and highlight all the commands you want to include in your script. I'll pick the 3 that we just typed. Then right-click these commands and hit Create Live Script. You'll notice that just like before, the live editor pops up on top of the command window, but this time it already has the commands that we highlighted. Now, to run this script, I first have to save my file by going to Save, Save As, and giving it a relevant name. Then I'll go to the top here where it says Run All and hit that button. When I do this, all of the commands in the script are executed. We can see in our workspace that 2 vectors, x and y, were created. And right next to our code, we see the figure that was generated from the plot command. Based on your preference, you can choose whether to have these outputs on the side of your code or in line with your code. These two buttons up here will let you switch between the modes. I'll switch to inline mode so you can see what it looks like. Okay, so the program we wrote so far is pretty simple. I want to go through a few tasks that you may use while writing something more complex. Task number 1 is adding comments. Comments will help make your code understandable. Typically, they'll describe what your code is doing. You can add a comment by typing a % and then typing your comment like this. Another way to organize your code is to add sections to it. What do I mean by this? Well, when using live scripts in MATLAB, you don't have to run the entire file. You have the option to run your code section by section. Sections will also visually split up your code, making it easier to read and comprehend. To add a section, I'll type 2 % followed by a space and the name of my section. When I hit enter, we'll see a visual break in the code that separates the section I just created. Let's put a couple of commands here to show you how to run a specific section of code. I'll create a vector x with values 1 to 100, and I'll create another vector y with values 101 to 200. And then I'll plot x comma y and make the plot red. Now, instead of hitting run all like I did before, I'll highlight the section I want to run and hit run section. We can see the figure that corresponds to the section pop up next to the code we just typed. And if we click on one of these plot commands, we can see that the corresponding figure is highlighted. This is a really useful feature for navigating through your results. Now, we've talked a little bit about formatting our code, but let's talk about some common tasks and constructs used in programming. The first thing that we'll talk about is called indexing. Indexing is used to take a subset of a vector or matrix that we already created. For example, let's look at one of the vectors we created earlier, y. If we open the variable editor, we can see that each element in y takes on a different value. Now, let's say we want to access the 5th element in this vector. We can type y and then in parentheses 5 to get this number. Or if we want the 7th element, we'll type y parentheses 7 close parentheses. Here's some practical examples of tasks that we can do with indexing. We can create a new variable a, which is equal to the 5th element in y. A equals y of 5. Now our workspace shows that a is equal to the same value as y of 5. Or we can change the 5th element of y to be 100. We'll type y of 5 equals 100, enter. And we can see that after executing this command, the 5th value of y has changed. Okay, one last example. Let's say we want to change the first 5 values of y to be the numbers 6 through 10. We can type y of 1:5 equals, and then in square brackets, 6, 7, 8, 9, 10. When we hit enter, we can see that the first 5 values of y have changed accordingly. So this covers some of the basics of indexing, and the next thing I want to talk about is something called the if-else statement. You'll use an if-else statement if you want to execute a set of commands only if a certain expression is true. This will be more clear with an example. Let's start by writing a statement that takes in a user input. The line of code I just typed is going to ask for input from the user and convert their answer to a string before proceeding. I'll show you what I mean. If we run this section, it asks us, did you learn something in the command window? Whatever we type as our answer will be stored in the variable user_in as a string. Now that we have our user input, we'll create an if-else statement that determines what to do based on that user's input. So I'll type it all out and then we can go through it. Starting from the top. If the user types y, then the first expression user_in equals y is true and will display hooray. But if the user does not type y and types n instead, then the second expression is true and will display, oh man. Finally, if the user types anything that's not y or n, will display, please reread the directions. So let's actually run the program for the three cases. I'll hit run section and answer the question with Y for yes. The live editor executes the code in the if section and displays hooray. I'll run it again, and this time I'll answer the question with N for no. This time, the live editor executes the code in the else if statement and displays, oh man. I'll run it one last time and I'll type something different as my answer. Now, the live editor executes the code in the else section and displays, please reread the directions. Now, one last thing. It's important to note that you can only have one if and one else in each construct, but you can have multiple else if statements. For example, I can add in the following section. Now, if I run this section and respond with Q, the third expression is true, and the live editor displays, why did you type Q? The last construct that we'll talk about is called loops. Specifically, we're going to talk about for loops. Loops are used to repeat a set of commands within your code. So I have a function that'll help us illustrate when this comes in handy. The function is called random walk, and I'll give you a visual explanation of how it works. There's a person who's standing a certain number of steps away from his home. Let's just call him LeBron. In the function, LeBron flips a coin, and if it lands heads, he takes one step towards his home. And if it lands tails, he takes one step away from his home. The question is, how many coin flips will it take LeBron to get back to his home? So the input for the function is going to be his starting position, and when we run the function, it automatically simulates his coin flips until he reaches his house. So the output for the function will be the number of coin flips that it took him to get home. For this example, let's say LeBron always starts 3 steps from his house. So the input for the function will be 3. If I hit run, we can see that it took 15 coin flips to get back home. Let's run it a couple more times and see what results we get. Okay, notice how every time the result is different. And at this point, you might be curious, if we ran this 100 times, what would be the average number of coin flips that it would take LeBron to get home? Or maybe you're just wondering what the entire distribution would look like. Instead of rewriting the same command 100 times, you can create a loop, in this case, a for loop. So let me show you what I mean. I'll type it out and then I'll explain what's going on. All right, so what does all of this mean? Well, our first statement is for I equals 1:100. In this case, I is called an index variable. It's responsible for counting the number of iterations we go through in our loop. So in this case, we'll iterate through the loop 100 times, and I will take on values 1, 2, 3, 4, 5, 6, etc., all the way up until 100. Everything contained between the for and the end is going to be repeated 100 times. In this case, our function is within our loop, so this is what will be repeated. I'll walk us through a couple of iterations. When we first enter the loop, I is equal to 1. And then we hit our statement, num flips of I is equal to random walk of 3. This is going to create a variable called num flips. Remember that I is equal to 1. So when we have I in parentheses, we are indexing into the first element of num flips. We're going to set that value equal to the output of random walk of 3. We reach the end of our loop, so we go back to the top, and this time I is equal to 2. Then we'll hit our function again. This time, it will index into the second element of num flips and set that value equal to the output of our function. We hit the end of the loop, so we go back to the top, and this time I is equal to 3. Again, we'll execute the random walk function, and this time the result is stored in the third element of the vector. We keep going through this loop until I is equal to 100. And each time we go through it, we add one more element to our vector num flips. So after 100 iterations, we'll have a vector that has 100 elements in it. So let's go ahead and run this and take a look at the results in the variable editor. Here's our vector with all 100 elements. Now let's do some basic analysis. One thing we might want to do is to check the mean of the data. We'll go back to the command window and use the mean command. Whoa, that seems kind of high. You might be curious to see why it's so high, so let's plot the number of flips that it took on each trial, just as a sanity check. Okay, we can see that some trials took thousands of flips until LeBron got back home. So that's definitely skewing our mean to the higher side. Since we have several large outliers in our distribution, the median may give a better understanding of the data's central tendency. So let's type median of num flips and see what we get. Okay, that's a little bit closer to what we want. So once we know what kind of analysis we want to do, we can then take those lines and add them to the live editor, and then go ahead and save the program. So that wraps up this video on creating a basic MATLAB program. The examples in this video were pretty simple to illustrate the logic, but these basic principles are applicable for everything from analyzing big data all the way to creating a graphical user interface. And the best way to get familiar with writing MATLAB programs is to practice. If you get stuck, there's plenty of resources on mathworks.com, and you can post your questions in MATLAB answers as well. Thanks for tuning in, and I'll see you guys in another video. Hello.
Okay, well, let's think of some of the things that they covered there. Even this very basic example, you could see how they were doing like what ifs, doing a little bit of analysis, then thinking a little bit more, trying this, trying that, and then kind of progressing in their involvement with their data. So that's kind of what I would like to have you guys do with your project and think about that. So one of the steps is related to the things that we're trying to cover here, computational analysis, solving for things. If you have a truss and you're trying to make sure that it doesn't deviate by more than 5 centimeters or something like that, or whatever it might be, how efficient would it be to collect 100 tons of plastic in the ocean and recycle it? And you could be thinking about how efficient it would be to collect it, how much would it cost to recycle it, what are the actual resources that are available to do that if we wanted to do that in the next year. Those are just examples of the kind of things that we were starting to see with that example. So they used an artificial example, trying to just random walk examples, heads or tails. You're either going closer to or walking away from home. That's pretty much what I wanted to cover here. The only other thing that they have here is symbolic mathematics, and I'm not going to get into that into detail, but basically you can solve an equation. So if you have one unknown in one equation, it can come up with what the answer is. And that's just the simple way of thinking about that. Any comments or questions that come to mind as we think about some of the capabilities we have with MATLAB and what we might be able to do? So if it's not MATLAB, are you getting a little bit of perspective that in terms of analyzing, comparing, optimizing, what you have, where you might go with that? Does that help you a little bit on that? Thumbs up if it does, or okay, good. Well, we're just about out of time, so I'll just quickly go over to our summary of projects. And any comments that pop out for you before we call it a day for how this is going to be helpful for you? Go ahead. Yeah. Yeah.
As I saw that there was a feature to report in Excel,
Yeah,
so is it really compatible with Excel, like in regards to like the project? I know it's not on box of data.
mhm.
I can do it in both Excel or in Excel. let's see.
Yeah, and both are good options, so I don't think you can have a bad choice there. The learning curve is probably less in Excel, but then getting a chance to try it in MATLAB, like I have the link that you can get a free version of MATLAB and you get they keep changing a little bit, but I think it's so many hours a month or something like that. Yeah, so you can give that a shot. And I think we do have some lab computers here with the department that also have MATLAB. And so if you run into some challenges, we might be able to set you up with something like that as well. Okay. Good. Thank you for giving us some feedback. Can be eye-opening just to think of the realm of possibility. We want to keep adding tools to our toolbox of things that we could be considering as we flesh these things out. Any other comments? Any computer science guys have any comments? I know this may be a little bit out your wheelhouse, but I'll be sure I can show you some examples with machine learning that I leverage in another class, like for clustering and stuff like that. It's okay to say, I didn't see anything, but any observations? With, yeah, that's a good point. Any language, you're gonna have to learn the syntax, and it is different. It's not the same as Java or C++ or Python. Some things are similar, but yeah, so that can be a frustration. But I was trying to have people just see the bigger picture, but you bring up some real points, and I'm glad you were understanding the terms. May not be the tool of choice, but it just gives you an idea of something that is out there. Okay, I think we'll call it quits for there, and Thursday we'll continue to be thinking about this area. And also keep allowing for time for us to have discussions about our projects. Okay, thank you, everybody.